Okay, the second question that we have here is a little bit trickier, and I have included a photograph of a 3D version of this that I'll explain as we go through the problem. So it says here that from the top of a cliff 160 meters high, two buoys are observed. So they're off floating in some water, and their bearings are 337 degrees and 308 degrees. Their respective angles of depression are 3 degrees and 5 degrees. And it wants us to calculate the distance between the buoys correct to the nearest metre. So this is question 6 actually from 18F. Now in this photo, what I want you to look at here is that this glue stick is representing our cliff for us. I've labelled A being the base of the cliff and D being the top of the cliff, and just written a note here that that's 160 metres high. So that's our cliff here. When it talks about the bearings of the buoys being 337 and 308, that's from the cliff, and we think about that being from the base of the cliff. So I might actually redraw their bearings just as a tree layout for us here. So I'm going to label the center of this compass as A, being the base of my cliff. Now it tells us that one bearing is 337 degrees and one is 308. So my 308 one, that will be out here, and we'll call that 308 degrees. Okay, and in that photo that I've put there, that first buoy is the glue stick here at B. So I've labelled it with B down here for us as well. And the next buoy, is on a bearing of 337 degrees. So that's out here, that's C. And so that's telling me that this whole bit around here is 337 degrees. And so in my diagram up the top, that's that second glue stick here as C. Okay. What we can see there is these two lines, they do create a triangle for us here. We can fill that in and we can call this X. That's my end goal that I want to find. I want to find out the distance between those two buoys correct to the nearest meter. But I need to work out a few things first, and that is that I need to work out how far each buoy is from the base of the cliff. Now, in terms of me thinking about how far they are from the base of the cliff, so that's me working on this horizontal plane or working out these C to A and A to B distances. This is where my angles of depression are going to come into it. So when we read this question, it's got the word here respective angles of depression, and it's got the angles in an order. What that means is that the order that we started with, they then correspond to each other. So the buoy that's on the bearing of 337 degrees, it's on an angle of depression of 3 degrees. And the one that's on 308 degrees, that's on a bearing of 5 degrees. Now, the buoy that was on that bearing of 337, that's my buoy C. So I'm going to actually now draw us a diagram where we're now going to look in this 3D space, but looking at the vertical part. So this, where it's talking about the angle of depression, it's now meaning from the top of the cliff out to that buoy there. So this here is actually going to be D, this is A, and this is C. And we know that the cliff is 160 meters high, and I need to draw in this line of sight to help me draw the angle of depression. We know that angles of depression get measured from the line of sight, from the horizon down to the line of sight. So this one here will be 3 degrees. Sorry, that's just written a bit funky. And that means that this alternate angle down here is also 3 degrees. Now looking at this, I want to find CA, and it's a right angle triangle, so I can label this with O and A so I can use SOHCAHTOA. And if that's the case, I'm going to be using tan. So we're going to say here that tan of 3 degrees is equal to my opposite 160 over my adjacent, which is CA. And if I rearrange this now, that tells me that CA is equal to 160 over tan, 3 degrees. That is my most accurate form of the answer. My final answer needs to be to nearest meter. So if I like, I could pop this in my calculator here, 160 over tan 3. And I could write it with some decimal places here. So let's write it to 4 decimal places. We've got 3052.9819 meters. If you look at that photograph that I've inserted, that 160 over 10(3), that's that writing in pink. That's already labelled there. Now, I want to look at now boy B. So let's draw again another right angle triangle. This time out to boy B. I've got D and A again, which is 160 meters being the height. And if I now look at this, I've got my horizon line. We know that the angle of depression to B is 5 degrees, so that's 5 there. And I've got then this angle down here being alternate, also 5 degrees. Again, I've got a right angle triangle. I'm finding BA here. And so again, I've got the opposite and the adjacent. I'm going to use tan. So tan of 5 degrees this time is equal to 160 over BA. That means BA is equal to 160 over tan of 5 degrees. And again, let's chuck that in my calculator for me. 160 over tan 5. And that's 1828.8084. So, what I now know, okay, is I now know those distances from each buoy to the base of the cliff. So if I look at the photograph, I can see I've put those fractions there in the purple and the pink. And if we look at the diagram that I drew on this for us, what we could then label as well is we could label this one here as being 1828.8084. And A to C up here as 3052.9819. So what we now need to do is we can use this blue triangle that I've got drawn, ABC, for us to find side X. But I do need to know then what this angle in here is, theta. What we know is we've got those two bearings. So that angle theta is actually the difference between the two bearings. So that's going to be 337 minus 308. So that gives me an angle of 29 degrees that I'm going to work with. And because I've got this sandwich situation, remember I've got two side lengths and the angle between them. That means I'm going to use the cosine rule to find the length of that unknown side there, okay? I'm using the cosine rule to find x, so it's going to be the square root then of AC squared plus BC squared minus 2 times AC times BC times cos of theta, okay? I can now substitute this in. Remember, the most accurate way for me to do this would be to put in the fractions that we found before. So we said before that AC is 160 over tan 3. So we'll square that, plus then BC, which is 160. Sorry, I don't know why I wrote BC. I should have written BA the whole time. My bad. Let me just go back and edit that for us. I'm sorry for that. Sorry. This should be BA and BA. Sorry if I confused you. 160 over tan 5, and that will be squared, minus 2 times 160 over tan 3 times 160 over tan 5, all times cos of 29 degrees. I'm going to head to my calculator now. I just really need to carefully type all that in. I can highlight and copy those fractions in here, which will at least make my life a little easier. So let's select them and move them in for us. Then minus 2 times the first fraction and then times the second fraction, cos of 29. And now we can solve that. We get 1702.55. And in answer to our question, it did say find it to the nearest meter. So we're going to say then that the boys are 1,703 meters apart. With this type of question, it is tricky to perhaps see things on that 3D sort of plane. So I do actually really recommend you trying to play with like stuff you've got in your pencil case. See if you can make like the vertical aspects and the horizontal aspects like what exist in that photo that I've included there. Because I do just think that'll be helpful for you to help visualize what's going on. And then break it down into separate diagrams rather than try and draw everything in the one diagram as well. That's it from me for 18E and 18F. So I'm going to stop the video there. You do need to get all of the work finished, and if you have any questions, please let me know. Thank you.